Alright guys, today we'll be talking about separation of variables, and here's some important steps you need to remember. Okay, step number one is move all of the y terms including dy to one side of the equation, all the x terms including dx to the other side. Now there are some people that say you should move them both to the same side and have subtraction between them and then have it equal to 0. They're both the same thing. They just both have the same thing. Okay, step number two is integrate one side with respect to y and the other side with respect to x. Don't forget the plus c on both sides. Now on the left side, if you're integrating with respect to y, you might get c, and on the right side, you're integrating and then you integrate with respect to x and you get d. When you combine that c and d, and I'll explain more in a sec, they're both going to be a constant, to say the least. And then what you're going to do is you're going to simplify the best you can. Okay? Alright, so let's try out some simple ones first real fast. Okay, and a really easy one to work with is dy slash dx equals, let's say 3 times y. Okay, so there we go. Alright, so we have everything all set up right here. Okay, now if you notice, if I try to divide both sides by y, I'm going to move the y over here, and if I multiply both sides by dx, I will move the dx over here. Okay, so I'm going to divide both sides by y, so I'm going to get 1 over y times dy. I don't ever like to put the y underneath the dy, it's just not my thing. And then I'm going to multiply this by dx. Okay, so there we go. Alright, now that we've done that, we're going to integrate with respect to each side. Okay, so on this side, this is going to be the natural log of y. So this is natural log of y plus c equals, well, that 3 we're actually going to move this integration right here. So you're integrating the dx. Okay, so this is going to be 3 times x. There we go. Plus another type of c. It would be d. This is the d I'm talking about. Okay. Now, if we were to actually solve for y right here, and we were actually to solve for y, we would need to move the c over here. But here's the cool thing. When you minus c from both sides, and you minus c, you're just going to get a different variable. So the natural log of y is equal to 3x. You can make it a whatever letter you want. I'm just going to use a capital C just to connotate that. Okay, now in order to solve for y, we need to raise everything to the e power. So you raise it to the e, you raise this to the e, right? And that's the only way to get that stuff down to be able to work with it. So now what you're going to be dealing with is y equals e to the 3x plus c, and you can change it back to little c. You know, it connotates a different constant. Okay? Okay. So when it's all set up, you're just going to be looking like this and just working like this. Okay? Alright, now another thing is that if you notice the c is in the exponent, we can change this to be y equals e to the 3x and just have that be in the exponent, and then have the c down here. Okay? Alright. Now, the other cool thing is you can actually find out what the c is by knowing a point on the graph that actually works with it. Okay? Alright, so let's say that for some reason 1, 2 was actually part of it. So what you would do is you would actually plug this in for x and this in for y. Okay? And then you would just plug that in and solve it, and you would solve for c. So it would be 2 equals e to the 6 plus c, and then you would be able to find out what c is exactly. And c would actually be 2 minus e to the 6 equals c. And then you could actually take that and plug that back into this original equation and have this be y equals e to the 3x plus 2 minus e to the 6. Okay, and that would be your actual equation that you started out with. Okay, so separation of variables. Now, if you'd like to see if that would work, just do the derivative of this, and you should be able to get back to the actual equation at hand. And you are going to have to do some implicit differentiation to get there. Let's try out some more problems. Okay, now something that looks like this, xy dy equals x times y squared dx. Okay, so once again, get everything y on the left, get everything x on the right. Okay, so if I divide everything, I'm going to end up with 1 over y equals, or dy equals, will equal 1 dx. Okay, all right. Now, as I do the integral of both sides, my integrals are not the most nicest in the world. Do not forget your actual values. So natural log of y plus c is equal to x plus c, and then you can finish it from there on out by doing the same exact thing of what we just talked about. Okay? All right. Now, as for unlimited population growth, the example we just did before actually arrives to the actual equation of it. And in actuality, the only thing you need to change is you need to change this to a k, and you actually have your equation for it. Okay? All right, so unlimited population growth, that's talking about the fact that sometimes there might not be a parameter that actually keeps something from in check, you know, like a natural predator, so like human beings and stuff. So you'll be using this formula quite a bit, which is the actual formula of y equals a sub 0 e to the kt, okay, which is something that we've always worked with before. Okay, all right, so this right here is definitely going to be your initial population. This will be your constant of growth, and this will be your time. Okay, it's usually your rate right here. All right. Newton's law of cooling, you've worked with it enough in chemistry that you should know how to work with it. Okay. All right, now that's it for working with calculus with separation of variables. Just remember, follow these steps, and you should be able to separate your variables. All right, I'll talk to you later. Bye.